Yeah, so before we get started, let me just introduce ourselves. I'm Ruchika Suryawanshi. I'm a software engineer at JP Morgan Chase, along with my co-speaker Ruchi Pakhle. She's a software engineer at Red Hat. So let's just go through the agenda first of all. We'll start with what problems we as a developer face in our day-to-day life when we are working with especially the CDK applications. We'll see what is service integration testing, how dependency graph help us to analyze those services. Then we'll see how the local stack can help us to solve this problem, and we'll see how to set up the infrastructure with the help of Ansible, and then testing with the help of test container, followed by a demo where we'll be showing a small application which was deployed with the help of these three applications. And all the questions we can park it at the end of the session. So yes, so the developer challenges that we face in our day-to-day life. What the development cycle goes like, we develop a feature, then we commit it, push it, all the feature changes, everything, then PR approvals and all this thing happens, and then it goes through development. But what if then I realize, okay, I missed this certain test case at this point, but now my changes are already deployed. In this case, I have to do this process again. So I don't have any control on the cloud, what's happening. So the first problem is that I wanted, as a developer, I want that full control, how my services are going to interact with each other, and at what certain point it might get failed. So I want that control. Second is that in this entire cycle, develop, code, push, deploy, and understanding if there's any bug. So understanding that there might be an issue that at this certain stage that we get to know at the later point. So I want that control in the initial half. Secondly, in this point, in the entire flow, there's a lot of delay that happens. Second is that there's a cost. So when we are calling cloud services, it comes with a cost. There's a billing factor. So for testing, I don't have to rely on something that includes costing. And again, there's a huge workflow. And the third problem is, again, it's a very standard problem that we all must have seen, is that it works on my local, but doesn't work on the actual cloud. It might be certain issues like dependencies might be failing, one dependent service might be dependent on some other dependent service, and that dependent service might be failing. Or maybe the version in my local is different, and the version which is there in the cloud, it might be different, it's failing because of that. So these issues we are tackling in our day-to-day life that we could solve with the help of this thing, and how we can test it. So the next is service integration testing. So as we can see, when we have a large-scale application, there are multiple services that are involved. So these services interact with each other. So when there's a lot of large-scale services are interacting with each other, there is a huge dependency issue can be done. So we have to test each service when one service is interacting with the other and how they will be performing. So when all the components will be interacting with each other, I want to make sure what would be the next expected output. So that should be matched. I want this entire thing in my local. So that could help us in the integration testing, and this could help us to not take those bugs in the production level. We could solve it in the CI integration part. Next comes is understanding the dependency graph. As I have mentioned, understanding the dependency, it's itself a huge task, since there are a lot of services that are interacting with each other. So it's always best to draw a dependency graph which will help us to visualize how the dependencies are interacting with each other, resources are collaborating with each other, and what exactly the mind map looks like. This will also help us to understand both the internal and external dependencies that happen. Next is that we could, at the initial phase, while we are creating certain integration testing, we are able to understand the entire flow, that how services are going to interact, so that we can write more effective service integration testing. So here it comes local stack. So local stack is a simulator which will take your entire AWS services in your local. You don't have to pay anything. It will be a simulation of all the services, be it S3, be it any databases you are using. It will simulate that on your local. directly. It is not going to affect your cost at any, because it is not actually calling the AWS. So you can run the AWS application or Lambda entirely in your local machine without any remote connection to your cloud services. Third is that it's ideal for testing complex CDK application, especially when we are working with the cloud applications. Then it says that test AWS without any AWS connection. So you can have the entire local setup, AWS setup in your local. So let's just understand how the local stack architecture works. So first of all, we need to give a configuration, like what all services that I need to have in my entire application. It could be S3, some resources, what DB I want. I can give all of that in the configuration that will be stored in your environment variable. Then there is a persistent state. So whenever the local stack restart, it might refresh your state of maybe S3 or any database which you have, DynamoDB and anything. So that might cause some issues while testing it. So we can we can store that data in a state which is called as a directory, data_dir, where you can store these states of your services. Second comes here in this CI part, it comes your local stack. This local stack it acts like you are calling the actual AWS. So whenever the calls happen, API calls goes to the local stack and it will work as a AWS service. So if you are creating an application which takes the data, it stores those files into S3. So what it will do, it will take those files, it will store in the local setup. So it will work similarly what the AWS services are working. Then we have Lambda functions and Docker. Docker is something for Lambda functions, we need to create certain virtual environment that will be closed for certain Lambda functions, and it will also get stopped or destroyed once the work is done. So this is how the architecture works. Moving on, supported AWS services. So local stack emulates over 90 Amazon Web Services as of now, and these are the core services that we all have. Then these are the multiple options which you can install the local stack in your machine. One is the Docker container, second is Docker Compose, and third is the GUI based Docker desktop application. It supports all three Mac, Windows and Linux. Then we can include the CI/CD workflow in our local stack. So whenever the developer pushes the code, it goes to the version control. After that, it goes to the CI runner. You can use any of your CI runner. Then there is a cloud pods for storing the state, your application, whatever the states that you are giving. Then there is a infrastructure where you can store how the infrastructure will be working. And the actual local stack sits over here. After testing all this part in the CI, it gives you a test report. In this part, majority of your test and the entire application is tested so that you won't feel any bugs in the deployment part. You can easily go to the CD pipeline part. So moving on, Ruchi will take over with what is Ansible. Thank you. Over to you, Ruchi.
Thank you, Ruchika. So now let's talk about what's Ansible. Ansible is an agentless automation tool that signifies configuration management, application deployment, and infrastructure orchestration. It uses like YAML-based files to write the playbooks and making it easy to automate your repetitive tasks, right? So one of Ansible's key strength is idempotency, meaning that you don't have to run it again and again, and when you will run it, it won't make the changes unless and until it's required, making it like consistency and prevents the unnecessary modifications. Another advantage is simplicity. Ansible does not require agents running on remote machines. It like you can just run it using SSH or APIs, and making the setup and maintenance very straightforward. And now when combined with LocalStack, Ansible can provision AWS like resources, allowing you to test infrastructure changes in a safe and controlled environment before deploying to real AWS. So this makes it a powerful tool for DevOps workflows, CI/CD pipelines, and cloud infrastructure automation. Yeah, now that we know what Ansible is, let's dive into how it works. So Ansible follows like a declarative approach where if you define your desired state of your system, and Ansible ensures they match that state, right? So let's break it down. So we have the Ansible management node where like the management node is the node where Ansible is installed, and then we have our inventory file where you provide, like you define your target systems, and like it could be anything, right? It could be your Linux machine, Windows machine, it could be cloud services like AWS, GCP, Azure, or network devices for, in that case, like Cisco, Juniper, or Arista, right? So it's like a host.ini file where you define your host and variables to connect to the system. And then the next we have is modules and playbooks. So they are the building blocks, right? So like they handle the specific scripts, and you provide specific modules, roles and variables in the YAML file, which is the Ansible playbook. And using that, you can like create your devices. You can create like a playbook is a YAML file that contains one or more plays defining what should be done on each system. So, yep. Yeah, so the playbook syntax and structure, so we have different plays, and each plays have different tasks, and you can just run them using the Ansible playbook run command. Next slide, Ruchika. Yeah, so writing an Ansible playbook. So the example playbook could be, you can provide the name of the playbook. Then we have the hosts, where you provide your host, like web servers or any target system that you want to define there. And if you want to run it as a root user, you can just give it like a become user equal to root and become variable as yes in that case. And you can define specific tasks. So first task could be like ensure Apache is at the latest version, and you are like just installing the HTTPD package. And next would be ensure Apache is running, and service could be like, yeah, HTTPD, and state is started. So yeah, so integrating Ansible within LocalStack. So we use Ansible playbooks to automate the setup and configuration of LocalStack. So Ansible uses like provision AWS like resources, and it uses Ansible tasks to create the resources, S3 buckets, DynamoDB tables, and you can just preset the data into this like Ansible playbook, create files, and yep. So you can just like create a LocalStack container using the Ansible by defining specific tasks here. Then we have testing using test containers. So test containers is basically an open source library for like bootstrapping real dependencies. So we have lots of dependencies in our code, right? It could be like databases, message brokers, orchestrators, web browsers, like there could be multiple dependencies. So test containers provides an easy way, like lightweight APIs to connect to those and tear them down step by step. So they just run, like using the test containers, it just runs your integration test. It just runs them on the container. It and yep, it also destroys them after the this thing. So yep. Yeah, so next slide is like what problems do test containers actually solve, right? So we have like a cloud native infrastructure and microservices in our code base. So example, I have my service running and it's connected to a data store, and then we have like API gateways which is connected to different services in this case, and we have our message broker Kafka, which like produces, yeah, the producers receive the data and it consumes it from from a different service, and then it pushes to the cloud. So everything related to testing is done inside the my service application, and a full-fledged test comes out of it. So so what I own, test, and deploy, you can just have full control over those, and it doesn't break your CI as well. So that's a great thing, right? Yeah. So test containers, Ansible plus LocalStack provides a automated AWS testing, and how it works is like Ansible orchestration. It provides an infrastructure platform which runs playbooks to spin up and configure the LocalStack with the required AWS services, and it executes them, like automatically launches a fresh LocalStack container for each test run, providing it a very realistic approach to manage your databases. And yeah, I guess we don't have the time for demo, but yep, so we can skip it.
Yeah.
Okay, thank you. Thank you so much.